Now, the next thing I want to talk about is, again, we're still on the topic of finding the domain of a relation, but this time we want to talk about relations in terms of equations. Now, we have seen that we can express, we can often express relations as equations, and so we want to try and find the domain from the equation of a relation. Now, what we are going to do for the purposes of this book is we are actually going to look at this agreement right here. Now, this says here, in this book, we assume the following agreement on domain of a relation. And the agreement is, unless specified otherwise, the domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. And again, remember, your independent variable is usually our x variable, or we use the letter x to represent our independent variable. So we are going to assume this agreement, which says again that the domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. So let's try and understand this agreement just a little bit better here. And let's look at some examples here. Let's say we have this equation here, y equals negative 5x. Now, in this case, basically the idea is that if I were to plug in any value for the x variable, what sort of value would I come up with the y variable? And you can try plugging in any numbers. Put in 0, you'll see y will be 0. Put in 1, you'll see y will be negative 5, so on and so forth. Just try a couple different numbers and see what happens. And you will notice that the domain for this function, and again, domain means the values for the independent variable, the x variable, will be the set of all real numbers Okay, so that was our first example. Let's look at another one here. Y equals 3 over x. Now again, you want to try and apply the same logic here. Try and plug in any real number for your x and see what sort of values you come up with for your y. Now there will be one restriction to this example here. As you can see, your x is in the denominator. You have 3 over x. If I were to use 0 for my value of x, you will see that you will end up with y equals 3 over 0. And of course, we cannot divide by 0, and you will end up with y equals being an undefined value. So that tells me I cannot really use 0 because, again, we cannot divide by 0. So we leave the 0 outside our domain. We don't include that in our domain. So in this case, your domain will be the set of all real numbers except 0. Now, to write this in our interval notation, And by interval notation, I mean, like in this example, the first one, when we said our domain was all real numbers, we would use the notation negative infinity to positive infinity. In this case, we are saying that our domain is all real numbers except 0. So that tells me I'm starting at negative infinity, but I'm stopping at 0 because I don't want to use 0 in my answers. And you will see that I'm using a parenthesis instead of a bracket, because that tells me I am not including 0 in my answer. So this took care of negative infinity to 0, but then you have numbers on the other side of 0. And for that notation, we will use 0 to positive infinity. So basically, this tells me all the numbers from negative infinity to 0, not including 0, and all numbers from 0 to positive infinity, again, not including 0. And to join these two, I will use my union symbol. And this is how you will represent it in your interval notation. To understand this better, if I show you the x-axis, basically we are saying this is your negative infinity right here, this is your positive infinity, and there's your 0 right in the middle. So we are saying we're including all of these values right here from negative infinity to 0, and all the values from 0 to infinity, but we are just not including 0 itself. Okay? So that's the domain for this function, y equals 3 over x. And this will be true for any function where you have x by itself in the denominator. You will have to exclude 0 from that domain, because again, 0 makes your y undefined, and we cannot have that. So in general, we can say that the domain of a function defined by an algebraic expression is all real numbers except those numbers that lead to division by 0 or an even root of a negative number. Now, when I say even root of a negative number, I'm basically saying if you take the square root of something. Let's look at this example right here. Let's look at this example, y equals square root of x. So you can see this is an even root, square root, and what happens to my domain here now? Now remember, anytime you have a square root, if you have square root of 4, that will give you a positive 2. But if you have a square root of negative 4, you cannot take the square root of negative 4 because the idea is if I were to square my 2 here, let's look at this one here. If I were to square my 2, 2 times 2 gives you a positive 4. If I take negative 2 and square it, it still gives me a positive 4. So you just cannot have a negative inside your even roots. And even roots are, square root, fourth root, sixth root, all of those. You cannot have a negative value inside. So using that idea, this tells me that my x here, x has to be greater than or equal to 0. Now you can take the square root of 0, which is just 0. Okay? So here your x has to be either a positive number or it can be 0. It cannot be a negative number. So when you talk about the domain of this function, you will say the domain is 0 to positive infinity, including 0. We're just skipping all the negative numbers completely here. So there you have it. Okay, your 3 different examples of how to find the domain using the equation of a given relation.